Alright, so now that we've had our discussion about units and conversion factors, we're finally ready to talk about some problem solving. So one of the most important and powerful skills that you'll learn in this course is how to attack a problem. And that's why chemistry is useful for the other natural sciences, it's useful for the health sciences, because it teaches you how to think about a problem in a different way than maybe you have before. And now problem solving skills, again, it may take you a while to catch on. We have the way that the text teaches problem solving, especially through the use of conversion factors, is a powerful method, but it may be different for you and it may just take a little getting used to. So please don't give up, just stick with it. Or if you already have a strategy that works, as long as it works all the time, it's fine, but we'll be doing pretty lengthy problems now, and it's probably a good idea to reinvestigate your own strategy and see if maybe this one is a little better suited for what we'll do in the course. The very nice thing about using conversion factors to solve problems is as long as you have your setup correct, there's really very little places you can get yourself in trouble. So hopefully if you haven't used this approach before, you're open to it and it works well for you, because really if you set up the problem correctly and if you're careful with your calculations, then the conversion factors really lead you along the way to get the correct answer every time. So if we're going to apply this strategy, first we need to state the given and needed quantities, so what you have from the problem and then what you're ultimately solving for, especially with respect to units. You can write up a plan to convert the given unit to the needed unit, right? We have all of those equalities that we can make into conversion factors to convert between units within the metric system or within the English system or across systems. So the third step is to state those equalities and express those equalities as the appropriate conversion factor. It does matter if you put, say, 100 centimeters in the numerator and 1 meter in the denominator, or vice versa, because given the quantities you have in the problem, you'll need to cancel in a certain way. And then finally set up the problem so that it's a single calculation that leads from left to right and ultimately to the final answer at the other side of the equal sign, and that the units will cancel correctly, meaning that you have the right units in the numerator and denominator to cancel the units along the way and end with an answer that has the appropriate units at the very end. And of course the numerical things, hopefully you're careful with your calculations as well, but the setup is key. Let's start with a relatively easy problem. So if the question is, if a person weighs 164 pounds, what is that person's body mass in kilograms? So if we apply those steps that we just discussed, step 1, state the given and needed quantities and analyze the problem. So we're given 164 pounds. We need to know what that amount relates to in kilograms. For step 2, write a plan to convert the given unit to the needed unit. So we have the pounds as our given unit, the kilogram is our needed unit, and we know that it's going to involve some sort of US to metric factor, right? Pound is in the English system, the unit system we use here in the US standard, and then finally, of course, we want to end up with the more standard worldwide metric system unit. In step 3, we want to state the equalities and conversion factors. So this would be provided in the test question, or you can certainly look it up for homework sets or end of chapter questions. 1 kilogram is equal to 2.20 pounds, and the way we can express that as conversion factors would be either 2.20 pounds in the numerator and 1 kilogram in the denominator, or the inverse of that. So now when we set up the problem, notice we do have to go with the 1 kilogram in the numerator, the 2.20 pounds in the denominator. We went with 2.20 pounds in the numerator and 1 kilogram in the denominator, the pounds wouldn't cancel. We'd end up with final units of pounds squared per kilogram, and that's wrong. Mathematically it's wrong, because we'd end up multiplying by 2.2 pounds instead of dividing through. So be careful. It does matter which conversion factor you select. Even though they're both equal and true and valid, only one is going to fit the problem correctly. So when we identify that one and we set it up to have the 164 pounds times 1 kilogram over 2.20 pounds, the pound units will cancel because we have a pound in the numerator. If it helps, you could put that 164 over 1 if you want to make that a fraction as well. If you're fine with this, this is also an acceptable way to represent it. The pounds in that numerator cancel with the pound in the denominator of our conversion factor, and we end up with an overall value of 74.5 kilograms. Probably the best argument for switching to kilograms for body mass, because look at that. This person went from 164 pounds down to 74.5 kilograms without dieting, without exercise, just by switching units. Alright, so we just worked that one together. Let's see how you do on your own here. Here's a learning check question. How many minutes are in 2.5 hours? So go ahead, apply those 4 steps, and pause the video. That's going to take you a couple minutes, I'm sure, and then start back up, and we'll see how you did. Alright, so if you apply our strategy exactly, in step 1, we would state the given and needed quantities. So here we're given 2.5 hours, and we ultimately want to know how many minutes that relates to. Step 2, we'd write a plan for how we're going to convert the given unit to the needed unit. So hour to minutes is going to involve some sort of time factor. Moving into step 3, we're going to state the equalities and the conversion factors. So 1 hour equals 60 minutes. So we could have either 60 minutes over 1 hour, or we could have 1 hour over 60 minutes. But you probably already caught on that we really need the hour unit in the denominator, because we're starting with the hour unit in the numerator of that 2.5 hours. And then finally, step 4 would involve setting up the problem to cancel units and calculate the correct answer. So we have our 2.5 hours times 60 minutes over 1 hour, and therefore the hour there in that 2.5 hours, which could be 2.5 hours over 1 if you preferred to have that as a fraction as well. That's certainly acceptable. But again, that hours is understood to be in the numerator. Even though we don't show it as a fraction, it cancels with the hour in the denominator of our conversion factor, and then when we multiply the 2.5 by 60 minutes, we end up with 150 minutes. Notice we did that to 2 sig figs because we had the 2 sig figs in our 2.5 hours that was given. Okay, so hopefully you did very well on that. If not, please practice more end of chapter problems, or contact me, and let's get you the help that you need. Alright, let's follow up with another learning check. Here we have a rattlesnake is 2.44 meters long. How many centimeters long is the snake? And this is multiple choice, like your test questions will be. So choice A, 2,440 centimeters. Choice B, 244 centimeters. Or choice C, 24.4 centimeters. So go ahead, take a moment to select your answer, pause the video if needed, and we'll see how you did. Alright, so hopefully you set this up as a standard question. You didn't just pick a multiple choice answer randomly. So step 1, of course, what you're given and what you need. So you're given 2.44 meters. You need an answer in centimeters. Step 2 involves writing that plan. So you need to go from meters to centimeters. Those are both metric units, so there's going to involve some metric conversion there. Alright, and then moving on to step 3, you're going to state the equalities and the conversion factors. So 1 meter equals 100 centimeters. We lost the unit there, but it's present in our conversion factors. So 100 centimeters over 1 meter and 1 meter over 100 centimeters. Obviously, 1 is the one that we're after, and hopefully you've already caught on that if we look back at that unit we started with, 2.44 meters, it's going to need to be the meter in the denominator here for our conversion factor. So when you move on to step 4 and set that up correctly, you'll cancel the meter unit and you'll end up with a final answer of 244 centimeters. It's 3 sig figs. Of course, in the multiple choice question where all the answer choices had 3 sig figs, that's not so important, but hopefully you're always following sig figs and paying attention to the sig fig rules, with the conversion factors being infinitely significant with equalities within the metric system. So answer choice B was the correct answer. Hopefully that's what you selected, and hopefully you didn't just get lucky. You attacked the problem in the correct way and you understand how this all works. Alright, so we've looked at a couple examples now of a simple conversion. And again, I don't mean to say simple because it's necessarily easy, but simple meaning we start in one unit, we use a single conversion factor to get to a desired answer unit. Oftentimes in chemistry and in the health sciences or natural sciences, we have complex problems that involve multiple unit conversions, 2 or more factors, for instance. So The way that we would set it up is still a similar approach, but we may have, again, in our plan, going from Unit 1 to Unit 2 to Unit 3, so on and so forth, because it may take quite a strand before we get the final desired answer. So the typical solution for a 2 or more factor problem is going to look like the bottom, where we have the given unit, and then that unit will be in the denominator, and we'll have a new unit in the numerator of our conversion factor. Then we'll have another conversion factor where that unit that was in the numerator of our first conversion factor now drops down to the denominator of our second conversion factor. And finally, our desired unit, when we're using 2 factors, would be that unit 3 up in the numerator, and that's not going to cancel. That's going to be the unit of our final answer. So let's look at an example problem that could be solved with 2 conversion factors. How many minutes are in 1.6 days? So if we attack this as usual, we look at the first step stating what we're given and what we need. We're given 1.6 days. We need an answer in minutes. In step 2, we're going to write our plan, and our plan is going to involve starting with the days that we're given and then having a time factor to get us first into hours, and then finally from hours into minutes. If you happen to know how many minutes in a day, you could go directly, but that's not as common knowledge as how many hours in a day and how many minutes in an hour. It's much more typical to go through those 2 factors rather than to jump into it all at once. Okay, so if we move on to step 3, we're going to state our equalities and conversion factors. So we know that 1 day equals exactly 24 hours and 1 hour equals exactly 60 minutes. So we've got the 2 different ways to express each of those equalities. If we look for step 4, our final setup is going to involve starting with the 1.6 days and therefore selecting the day in the denominator, so 24 hours over 1 day rather than 1 day over 24 hours. And then now that we have hours in our numerator, we're going to want hours in the denominator of our second conversion factor, and that's going to mean that 60 minutes over 1 hour is going to be correct, and we're not going to choose the 1 hour over 60 minute variety. If we do this, and we have to be careful, we'll cancel all the units. That's easy enough to do. But we have to make sure that we multiply all the numerical portions together. Fortunately, our denominators are 1 times 1 times 1, if you really want to start with that 1.6 days over 1 as a fraction. So we've got to multiply 1.6 by 24 by 60, and we should end up with a final result of 2.3 times 10 to the 3 minutes. Of course, if we look at our beginning value, 1.6 days, that's 2 sig figs. This is multiplication and division, and therefore we should end with 2 sig figs, and that's why we've expressed our final answer as 2.3 times 10 to the 3 minutes. Let's follow up with a learning check, and in this case we're looking at an injured person loses 0.300 pints of blood. How many milliliters of blood would that be? And if this were, say, an exam question, you would expect me to give you the pints to liter conversion, but between liters and milliliters would be up to you. Alright, so I'm just making sure, because it's our first learning check on these multiple conversion factor problems, let's make sure we get our setup correct. So step 1, analyzing the question, we've got 0.300 pints is our given value. Ultimately, we want an answer with units of milliliters. So in step 2, we've got to have a plan that's going to first convert from pints into liters, because that's what you'll expect me to give you, is the number of pints in a liter, and then finally liters to milliliters. So go ahead and work on steps 3 and 4. Pause the video for the time you need to finish the question, and then we'll check and see how you did. Alright, so in this particular example, at least this solution shows 1 quart equaling 2 pints, and then 1 quart equaling 946 milliliters. So there's a couple equalities, and then the conversion factors, just expressing those as fractions. If you were on a test scenario, like I said, if I were to supply, for instance, the number of pints in a liter, then you would go pints to liters and then liters to milliliters. Here, based on one possible solution, we've looked at pints and quarts, and then quarts and milliliters. So it depends. If you have open access, like we do here in these lectures and in your homework sets, where you can find your conversion factors, you may find different conversion factors than I may have. But when we're all looking at a closed note, closed book exam, you would use the conversion factor I give that relates English and metric units. So here in this example, let's work through step 4 to get our final answer. We have 0.300 pints times, again, we want pint in the denominator, so they will cancel, so times 1 quart over 2 pints, and then times 946 milliliters over 1 quart, gives us a final answer of 142 milliliters. We started with 3 sig figs, right? That first 0 is just a placeholder. It's really the 300 that follow the decimal point that are significant. So we want an answer that's to 3 sig figs, and that's why we have 142 milliliters as our final answer. So again, you'd get that same final answer whether you went a different route with your conversion factors and inequalities, because there's many different ways to solve this correctly. However, as I said, in an exam setting, you'd have to rely on me for units that convert between English and metric units, so that sort of fixes things and keeps us all on the standard playing field. Alright, so hopefully you've started to get the hang of this, and dare I say these questions even get to be fun, so hopefully you can stop yourself from answering end of chapter questions and homework set questions, because you're going to get into the swing of things, and you're going to just really love these questions. If that's not true, then as I said, reach out to me for some guidance. Okay? Alright, good luck.